Hi, everybody. It's nice to be able to join you virtually. I'm going to be presenting on a cloud based toolkit for accessing hyperspectral data from NASA's PACE mission. Thank you to the ForestSat 2026 organizers, as well as my fellow session participants. In terms of the overview of this talk, I'll give you a little bit of context, talk about some of the main objectives, talk about what the features for the toolkit are. Um, since we won't have time for a demo, I will give you the link to the GE repo where you'll be able to access that. And then I know that after this recording, there are a few minutes for questions and answers. So, just to give you some context in terms of hyperspectral remote sensing, NASA's EO1 Hyperion instrument was the first hyperspectral imager that was launched in late 2000, but it started capturing imagery in early 2001, and that was decommissioned in 2017. There have been a number of hyperspectral missions since, but in terms of open missions or missions for which there's data openly available, those are mainly limited to NASA from the EMIT mission, which was launched in 2022, and PACE, which was launched in early 2024, and which I'll be speaking on in detail. However, I'd also like to call to everybody's attention that the company Planet recently launched an open data competition for its Tanager 1 satellite data, and you can find a link to that there below. As Morgane and Sky and Fred have already presented, there are a number of different PACE data products which are relevant to this ForestSat forest remote sensing community. In particular, there are a number of data sets covering the land surface. And again, one of the really interesting things about PACE compared to other hyperspectral instruments, not only is the data openly available, but the data is collected on a daily basis, which is really incomparable in terms of some of the other sensors, which only collect data fairly sporadically. In terms of data sets that are relevant to our purposes as well, not only is there surface reflectance provisional coming from PACE, but also a range of vegetation indices like you've heard in some of the earlier talks. Um, as you've also heard, you can access that data through multiple ways. Um, if you're just interested in viewing that data, NASA's Worldview platform provides a great way to view that data on a daily basis as it's acquired. And of course, there's also, if you're interested in downloading the data, accessing that data via NASA Earth Data Search, as well as the OBDAX level 3 and 4 browser. But one curiosity about that is because the data are so large, particularly global granules, um, at its full level of resolution, which is 1.2 kilometers, the global data, as it were, are something around 33 to 36 gigabytes large. And then, of course, if you resample that down to the 2 kilometer and 4 kilometer resolutions, then you're only talking about 6 to 7 gigabytes for the 2 kilometer data and 1 gigabyte for the 4 kilometer data. That said, though, I know that people in this community generally like to do your remote sensing work at the finest spatial resolution available, and so grabbing multiple 36 kilometer gigabyte granules, uh, could be challenging. So that comes to why did we want to put together a toolkit? And so I've been working on this toolkit in coordination with folks like Morgane for over a year now. And the general idea was to support not just the community of people who want to use hyperspectral data, but particularly those who are already working with platforms like Google Earth Engine, which facilitate work with big Earth data, but also the fact that GEE provides access to other data sets, whether it be the hyperspectral data catalog from EMIT to other data sets structural, like from JEDI, spaceborne lidar, and other data sets like MODIS, Landsat, Sentinel-2, etc., which again are pretty familiar for the community here. In addition to that, though, we wanted to provide not just access to PACE data through GEE, but also to provide access to the tools that GE facilitates access to, because again, having the data isn't enough. And by having the data in GEE and having access to those tools, we give users a head start to be able to work with those data sets. And so this is one example of that. Just again, there's a tool, toolkit, this repository of code for interacting with PACE data. And here's one example, which is allowing you to see then, at the, in this case, at roughly 10-kilometer resolution or zero point 0.1 degree, you're looking at the full global data set again for multiple months, and you can interact with those. However, giving you just, I guess, a little bit of background as to how we're getting that data in to Earth Engine. It's an engaged process, and in terms of the different products that we're pulling, as you heard from Morgane's and Sky's and Fred's presentations, there are a number of different data sets available for PACE from the Ocean Color Instrument, OCI. However, for this community, we'll largely focus on surface reflectance and vegetation indices, and just say we grab that data, we process it using SNAP or CDAS, we convert that into geotiffs from the original NetCDF data. We do limited processing of that data, like rescaling it, and then import it back into Earth Engine as image collections, and then make it available via this toolkit. And so in terms of what the toolkit does, it has 5 main features. The first one, as shown here, is data discovery. And so there are different tools, for instance, to be able to see when the most recent data are available. Just to mention that what's shown here isn't up to date, but just to say that, with the data discovery tools, we can also see, for instance, for any given area on the globe, not just what PACE data is available, but also be able to compare that with what data from Emit or Hyperion are also available. And so there are a number of scripts linked to data discovery, and the toolkit itself, the repository is organized into different sections. And then following that, after we've been able to discover data, we can also visualize data, for instance, by viewing images directly again, and they're available at different resolutions for different areas, such as the continental US or Mesoamerica. And then from that, be able to visualize spectral signatures. And so in this case, we're looking at data over the state of Alabama at a 2-kilometer resolution, but seeing, okay, what would the spectral reflectance look like coming from MODIS versus what would that hyperspectral signature look like coming from PACE OCI. In addition to being able to view spectral signatures, we're able to do basic time series analysis. And we can see some really interesting things that pertain to the phenology. And again, linking back to the presentation that you saw from Fred earlier. And I'm jumping over the part where for gap filling, but we're able to also do some basic machine learning, supervised and unsupervised classifications on the PACE data. In this case here, showing you what unsupervised classifications or clustering looks like, for instance, for the state of Alabama, based on multiple months of PACE OCI data, as well as for Mesoamerica. And also, just to give you a little bit of background as to what's there, I'd encourage you to, of course, to check out the overall GE repository. And one of the things you'll be able to see is that there are dependency packages that facilitate this work, such as one that loads in different hyperspectral functions, loads in the different wavelengths for PACE OCI, the wavelengths also for EO1 Hyperion, also for Emit, also for actually Tanager for the open data that recently became available, in which Sam Roy has loaded a lot of that data already into Earth Engine through his community repository. And of course, the equations for generating the different vegetation indices, as well as bad combinations for how to view the data. And of course, a data loader script, which, as mentioned there, provides samples for how to actually pull in the different data sets provided, as well as information on sample locations. Starting to wrap up other parts of the data loader again, just affirming there the different resolutions that we have the data available at, because just because it's a kind of monumental task, we're not able to load all of pace data into Earth Engine, but we're able to load, for instance, at the full native resolution, which is 1.2 kilometers. Select scenes for the continental US as well as for Mesoamerica, as well as the vegetation indices, etc. Um, in terms of how that data is updated, on this side, we try to update the data every 8 days as that VI data comes out, as well as provide access to monthly surface reflectance data, and then pulling select one data sets at the native resolution as appropriate, um, and plans for integrating other data sets as appropriate and available. Again, there's not time to do a demo, but I'd encourage you to check out the link that you see there or scan the QR code, and that will provide you access to the repository in GE where you can, at your leisure, explore these different tools and data sets as mentioned. And lastly, to wrap up, to acknowledge, of course, the organizers for ForestSat 2026, but also collaborators on the PACE team, the broader team, including Morgaine, Sky, and Fred, who also lead the PACE Land Data Users group or plug. Other collaborators that I have here at NASA Marshall Space Flight Center and also at the University of Alabama in Huntsville. And of course, collaborators from Google who've provided compute as well as space for being able to have the toolkit accessible. Thank you, and I look forward to the questions that you might have. Over.